Hello, and welcome to another lesson from Level Up Math. In today's lesson, we will be exploring the domain and range of a function and how to express the domain and range in interval and set builder notation. But first, let's start with a little bit of review. The domain of a function is the set of all allowable input values, which will produce a valid output from a particular function. The range is the set of all possible output values, which result from using a particular function. For example, the cost of a business to send postcards to potential customers is C of n equals 2.5n, when n represents the number of cards sent. What type of numbers would and would not be allowed as part of the domain of the function? Well, first of all, if you think about postcards, we can only send postcards in whole number values, like 1, 2, 3. So we couldn't send a half a postcard. We couldn't send 2.7 postcards. We also could not send any negative number of postcards. So we know that our allowable input values must be the set of positive integers. So for example, we could send 0 postcards, or 1, or 2, or 3, and on and on and on. So in this function, our domain is what we call restricted. It can't be any number it wants to be. It has to be in that set of positive integers. Now, in previous courses, you probably learned to express domain and range using inequality notion. But in this lesson, we're going to explore how to express domain and range in set builder and interval notation. Let's start off with interval notation. Interval notation uses brackets and parentheses to describe intervals of numbers. So if we had an interval that said 0 to 5, that's describing all the numbers from 0 to 5, but because they use parentheses, excluding the 0 and it's excluding the 5. So if we were to graph it, we would graph an open circle at 0, an open circle at 5, and then draw a line in between them. Our second interval has a bracket and then 0, 5. This means in this interval notation, we are including the 0. We're not including the 5. So our numbers could be anything from 0 all the way up to 4.99999, but they can never reach the 5. Okay? In our last interval notation, they've used 2 brackets, which means both the 0 and the 5 are included. So we would fill in the circles and draw a line in between it. So any number on that number line, 0.5, 1.8, pi, 2 1/4, any number on that number line would be included in that interval. Now, in our next example, they're going to give us a number line, and we're going to express that number line in set builder notation and interval notation. So in problem 1, we have a number line with -1 is not included, and then it's shaded to the right. So this means our included numbers are any number that is greater than -1. So in set builder notation, we use braces, and we would say the set of all x's such that x must be greater than -1. It's very similar to inequality notation. In interval notation, we would start at -1 and then we would continue on to infinity. So I'll write -1, comma, infinity. Now, infinity always gets a parenthesis. And in this problem, -1 is not included, so it also gets a parenthesis. In our second example, we have all the numbers that are less than or equal to +2. So for set builder notation, we'll say the set of all x's such that x is less than or equal to, because the 2 is included, 2. For interval notation, our smallest number is going to be -infinity. Our largest number is 2. The 2 is included, so it gets a bracket. And remember, -infinity, infinity always get parentheses. In our next example, we have the interval -2 to +3. They're both included. So our set builder notation would be the set of x's such that -2 is less than or equal to x, which is less than or equal to 3. In interval notation, we would have bracket 2, -2, comma 3, close bracket. In our next example, we have the interval from -3 to +2. So in set builder notation, we have the set of all x's such that -3 is less than or equal to x, which is less than 2. And for our interval notation, but -3 is our small number, 2 is our big number. 2 is not included, so it gets a parenthesis. -3 is included, so it gets a bracket. Now, in our next example, we have a compound inequality, and this says that x is less than or equal to -1, or x must be a number that is greater than or equal to 2. So in set builder notation, we'll say the set of all x's such that x is less than or equal to -1, or x is greater than or equal to 2. In set builder notation, we're going to have to do two different intervals here. The first one we'll do -infinity to -1, bracket and a parenthesis, and then 2 to +infinity. If you need to review any of these concepts, please pause the video before you continue. In example 3, we're going to give you some graphs, and we're going to ask you to express the domain and range in both set builder and interval notation for each graph. So in our first graph, problem A, it says express the domain in set builder notation. So in this graph, our smallest x value is -2, and our largest x value is 1, 2, 3, 4, is at +5. So to express this in set builder notation, we'll say the set of all x's such that -2 is less than x is less than or equal to 5. Now to express it in interval notation, we'll put our interval first, -2 to 5. The 5 is included, so it gets a bracket. The -2 is not, so it gets a parenthesis. Now, for the range, we're going to look at our y values. So, our smallest y value is at 0, and our largest y value, 1, 2, 3, is +4. So our set range and set builder notation would be the set of all the set of all y's such that 0 is less than y, which is less than or equal to 4. In an interval notation, we'll put our small number 0 and then our largest number 4. The 4 is included, so it gets a bracket, and the 0 is not, so it gets a parenthesis. In problem B, we have a function that is going off to the left forever on that side, and it's going off to the right forever on this side. So basically our smallest x value is negative infinity, and our largest x value, since it's going forever to the right, is positive infinity. So to put this in set notation, really what this means is that x can be any number. It can be any real number. So we can write it in shorthand way like this with a large capital R. And it kind of looks cursive, okay? And you can write it like this: the set of all x's such that negative infinity less than x less than positive infinity. It really just depends on how your teacher wants you to write it. So in interval notation, small number, negative infinity, largest number, positive infinity, 2 parentheses. Now, for the range, our smallest number is 2, and then it increases. So it goes to positive infinity. So it's going to be the set of all numbers, negative 2, It's going to be the set of all numbers, the set of all y values that are larger than negative 2 or greater than negative 2. So the set of all y's such that y is greater than or equal to negative 2. Now, in interval notation, our smallest number is negative 2. Our largest number is positive infinity. Positive infinity gets a parenthesis, and negative 2 gets a bracket. Again, if you'd like to repeat any of those concepts, just pause the video, rewind, and replay. In example C, we have a function that is opening downward. But same thing as example B. It goes off to the left forever, and it goes off to the right forever. So our domain is going to be all real numbers. And I like to have my students express it with this capital cursive R thing, but you should definitely check with your teacher on how they want you to express the all real numbers. Now, in interval notation, it's just going to be negative infinity, comma, positive infinity, then closed by parentheses. Now, for the range, we need the lowest value, which is negative infinity, and the top value, which is 1, 2, 3, 4. So our smallest value is negative infinity, and our top value is 4. So that means that this function, this V-shaped function, can only contain y values that are less than or equal to positive 4. So when I express this in set builder notation, I would say the set of y's such that y is less than or equal to positive 4. So in interval notation, our smallest number would be negative infinity. Our largest number would be 4. The 4 is included, so it gets a bracket, and infinity always gets a parenthesis. All right, problem D. Express the domain in set builder notation. So our smallest x value on this graph is 0, and our largest value is 5. So in set builder notation, we would say the set of all x's such that 0 is less than x is less than 5. They both have open circles, so neither of those values are included. So in interval notation, we would just go 0 to 5. All right, for the range, we need our smallest y value, which would be negative 5, and our largest y value. Now be careful here because your largest y value is up here at the top, and that would be positive 4. So in set builder notation, we would say the set of all y's such that negative 5 is less than y which is less than or equal to positive 4. And in interval notation, negative 5, comma 4, the 4 is included, the negative 5 is not. And that concludes today's lesson on domain and range.